So, welcome to the logic introduction. We are going to talk about what makes a conclusion valid. Now, when we did algebra proofs, it was valid if it followed one of our properties of equality or one of our definitions, right? So now we're going to talk in just logic terms. We're going to sort of represent our statements in notation and then decide if it's valid. So the new word here is valid. All planes have wings. We can say this is an if-then statement. We can say if it's a plane, then it has wings. So if P, then, this arrow represents a then, wings. All right? So this is our given statement. This is given, like our proofs. Therefore, all things with wings are planes. So can we conclude that all things with wings are planes? Is it always true that if planes then wings means all things with wings are planes? If W then P. And I can use a counterexample to disprove this one, right? I can say, well, what about a bird? A bird has wings and is not a plane. So I can use external logic and counterexamples to disprove it, but we need to recognize that this if-then statement is unidirectional. It is not bidirectional. It does not work the other way. When only given a unidirectional, a conditional statement, I cannot conclude. It is invalid to conclude. No, I cannot conclude that it works the other way. So even if it seemed to, and you're like, well, yeah, that seems reasonable, if all you're given is this statement, P then Q, or P then W, you cannot conclude W then P, even if it seems true. All right, so the truth value versus the valid or invalid conclusion are two different things. An explanation of the language of logic, the idea of making a statement that all planes lie inside the category of things with wings does not imply that all things with wings are planes. Planes doesn't fill the entire wings circle. These out in this pink area would be, for example, birds. We're going to learn some more ideas behind this logic stuff. Now, in this problem, it says all Bigfoots are monsters. So we're given, if it's a Bigfoot, then it's a monster. And we're also given all monsters are scary. So if M, then S. So the conclusion that we're wondering, is it valid or invalid to conclude? Is it valid or invalid to say then that all Bigfoots must be scary? So our directionality works well. If it's a Bigfoot, then it's a monster. If it's a monster, then it's scary. So can we cut out the middleman? That's the question. And the answer is yes. This looks just like our transitive property of equality and our transitive property of congruence. But instead of the transitive property of logic, which I would love to call it, we call this the law of syllogism. And that's just annoying, but it is. So syllogism is like transitive. It says that if B lies within M and M lies within S, then B has to lie within S. This is a valid conclusion. Yes. And it doesn't matter if Bigfoots don't exist, all right? We don't use external knowledge. We only use what we're given and then the laws of logic to see whether it's valid to conclude. Here's your Venn diagram to show that the given statements say Bigfoot lies entirely within the category of monsters and monsters lies entirely within the category of scary. Therefore, Bigfoot must lie entirely within the category of scary. And that is the law of syllogism. So here's a case where I'm actually going to start with the diagram because it helps me think about this situation. all bees are busy. We use the statement if bee, then busy, but we also use the diagram that if we are in this busy category, then all of the bees are here. Not everything busy is a bee, but every bee is busy. That's what that means, all bees. But outside of this circle that is all things busy is the not busy. Now, this symbol we've talked about in class used to mean approximation, but now it means not. It's the negation, all right? So a single squiggly line is not busy, so this means not busy. So there's busy and not busy. There's bees, and everything outside of the bee category is not bees, right? So some not bees are busy, and some not bees are not busy, right? All right, so that's how our inside and outside works. Let's look at this second statement. No slow things are busy. Now that's not the same thing as saying if something is not slow, then it's busy. That's different. It's not about slow versus busy. It just says that if it's a slow thing, then it is entirely in this realm of not busy. So we're going to write a slow things category out here that does not overlap because none of the slow things are in the busy category. All right. So if we've drawn this diagram correctly, we can we conclude, the question is it valid to conclude that no slow things, that all slow things are not bees, or no slow things are bees? So I'm actually going to ask the question, can I conclude that all slow things are not bees? Right? It's a little weird because the statement was no slow things are bees, but it's not that if it's not slow, then it's a bee. They're saying if it's slow, then it's not a bee. So if slow, then not bee. Can I conclude that? And the answer is yes, this is valid. Because if I look at my category out here, my diagram, none of my slow things can possibly overlap with the bee circle here. So hopefully that makes a little bit of sense. It's a little weird to translate that into the logic symbols, but drawing a diagram can really help. And here is Brilliant.org's explanation that's very similar to mine. Now stay with me. There are only two more examples. In this case, they say all knights are brave. So if, I'm going to actually go and use the letters that all of your worksheets and things are going to use. If P, then Q. P will be knights, Q will be brave. The other given statement is that all skilled people are, because skilled people we haven't come across yet, right? Knights, brave people, skilled people. And they're saying that all skilled people have done practice, so we'll call that S, PQRS, just because. Now, if P then Q, and if R then S, can we conclude that some, maybe, knights was P, have in fact done practice, which was S? Well, we know about knights and bravery. We know about skilled people and practice, but we don't know anything about knights and practice. I mean, this is where it gets into a key point that you should not ever use prior knowledge. We know that knights are skilled at different things. They've practiced things, of course, but we cannot draw connections that are not given. We can only use this, so we cannot conclude anything that crosses. We have 4 completely different categories, and we don't know, we can't even draw a Venn diagram because we only know that knights is inside the brave category, skilled people's inside the practice category, but is there an overlap? We don't know. So it is not valid to conclude. Not valid. Our last example here is going to demonstrate some other times where we have to translate that no idea. So this one says no pixel aliens are bright yellow. So what we say is over here we have the pixel aliens, and over here we have the bright yellow, and none of our pixel aliens are bright yellow. So they're all out in the bright yellow space, or the not bright yellow. So if pixel alien, then not bright yellow, and then we say all bright yellow things are from planet X. So if bright yellow, then from planet X. The question is, can we conclude that no pixel aliens? Now remember that pixel aliens are in this circle over here on the right, so out here is not pixel aliens, right? Which seems to fall into the bright yellow category, but look, bright yellow falls into the, well, does it fall into the not pixel aliens category? So we need to draw some circles. Where's the planet X category in all of this? All bright yellow things are from planet X. So perhaps the planet X is only bright yellow things, but perhaps it's not. Perhaps it includes some not bright yellow things. And if it includes some not bright yellow things, it might include some pixel alien things. See, so if this is my planet X, we don't know where planet X lies. So we cannot conclude that no pixel aliens are from planet X. And you can see it in the diagram. So the conclusion they're trying to draw is pixel aliens are not planet X. But out here is not planet X. That's X. Pixel aliens could fall in there. So this is invalid. No, invalid conclusion. Just because we don't know enough information. And a counterexample that I could use to prove this is to say, okay, I have a pixel alien who is blue. While he's not bright yellow, he could still be a blue planet Xian, right? Just because all yellow things are from planet X does not mean that all planet X things are bright yellow. That's an important statement. That's that whole, just because bright yellow implies planet X does not mean that planet X is only bright yellow. It's not a biconditional. All right. Good luck, logicians.